Hello, and welcome to this week's lesson, 6-3, 6-4, Making Comparative Inferences About Populations. For this week's lesson, you will need notebook paper and a pencil because you will be taking notes as you watch this video. You should keep the Google Doc open and be logged into Pearson. In these lessons, you will focus on how to make inferences about a population based on the data from a sample. We will focus on drawing inferences when the data is displayed in a box and whisker plot. But first, let's review some ideas from last week's lesson. A population is the entire group you are talking about. Sometimes a population is all the students in the 7th grade. Other times, a population is the players on a middle school sports team. A population doesn't always include thousands or millions of people. Samples are part of the population. Once you decide what your population is, then you determine your sample. You want your sample to be representative of the population. This means the characteristics of the population are shown in the sample. You also want your sample to be random. This means that all the members of the population have the same chance of being included. Picking names out of a hat or taking every 10th person from a list are two of the many ways to create a random sample. Inferences are not the same thing as a guarantee or a prediction. They're more like hypotheses. An inference is a statement that we make about a population using the data from the sample. That's why it's so important to have a sample that is representative and random. Remember to take notes as you watch and listen. Videos can be paused and rewatched. So do that if you need more time or need to see or hear something again. Measures of center are also called averages. You know the 3 measures of center, but might not know that's what we call them. You might not know that they're called averages either. The 3 measures of center are mean, median, and mode. We tend to use means and medians more than modes. The mean is probably the most familiar measure of center, and it's the best measure of center, or the best average, when the numbers in the data set are close to each other. In this example, notice how the data in the second column, all of those numbers are relatively close to one another. The median is the best measure of center, or the best average, when there are outliers, or numbers that are much larger or much smaller than the rest of the numbers. Notice the outliers in these tables. You'll notice the number of soccer players is far above some of the other values. And the number of people who have an MBA is much higher than the number of people who have other types of degrees. That's why we talk about a median house price in Melrose rather than a mean house price, because the prices of houses vary so much. Box and whisker plots do a great job of showing us how the data is spread out. We're going to focus on the minimum, or the lowest value, the median, the value in the middle, the maximum, which is the greatest value, the range, which is the distance between the maximum and minimum, and the interquartile range, which is the distance between the first quartile and the third quartile. Take a moment to study the diagram and read the information in purple and green. Press pause if you need more time with this information, but make sure you understand these big ideas and the big pieces of a box and whisker plot. Measures of center, like a median, describe the data using just one number. The box and whisker plots to the right show the number of customers who signed up for the loyalty programs at 2 stores over 12 months. Let's focus on the median. Which store has the greater median? Because store 2 has the greater median, we can infer that store 2 got more customers to sign up for their loyalty program on average compared to store 1. Now you're going to try. You're going to copy the sentence frame below and fill in the blanks. Use the box and whisker plot about students' heights to fill in the blanks. Hit the pause button and then press play when you're ready to check your answer. You may have said that you can infer that boys are taller than girls on average, or you may have said that you can infer that girls are shorter than boys on average by looking at the 2 medians on the box and whisker plots. A reminder that you should be taking notes as you watch and listen. Videos can be paused and rewatched, so do that if you need more time or need to see or hear something again. Next, we'll talk about measures of variability. Think about what the root word of the word variability is. Press the pause button if you need more time. The root of variability is the word vary. Measures of variability describe how much the data varies or how spread out it is. If the data doesn't vary much, then the numbers are all probably close or close-ish to each other. If the data does vary, then the numbers are spread out and there might be outliers. If the data doesn't vary much, then the numbers are probably close together. If the data does vary, then the numbers are spread out and there might be outliers. If there's a lot of variability, that means our inferences will be less valid or less reliable. Let's focus on the variability of these 2 data sets. In the first data set, we see that the ages of the students do not vary. In the second table, we notice that the number of hamburgers eaten each year varies quite a bit between the different people. Any inferences that we make about this data set will be less reliable because there's so much variability. Another way to say this is that the numbers are really spread out and they will have a larger range. In these lessons, we're going to focus on 2 measures of variability. Those are the range and the interquartile range. Last year, you learned about a measure of variability called the mean absolute deviation. You'll learn about something called standard deviation, which is another measure of variability, in future statistics classes. Another reminder that you should be taking notes as you watch and listen. Videos can be paused and rewatched, so do that if you need more time or need to see or hear something again. Box and whisker plots do a great job of showing us how the data is spread out. We're going to focus on the range in the interquartile range. The range describes how spread out the whole data set is. The interquartile range describes how spread out the middle 50% is. In this example from lesson 6.3, you'll notice that the range, minimum, maximum are all the same. And that tells us that Finn's data has the same or similar variability as Jonah's data. This means that the inferences we make are likely to be valid and reliable. At a quick glance, you might say that the interquartile ranges are the same, and that makes sense. This means the data is likely spread out the same in both data sets. Upon closer inspection, the interquartile range in Finn's dataset is slightly larger than that in Jonah's dataset. In this example, the range and interquartile range of company C are considerably smaller than those in company A and B. This means that there is much less variation in the data from company C. It also means that the data from company A and B are much more spread out and have more variability. Now you try. Copy the sentence frame below and fill in the blanks. Hit the pause button if you need more time, and then continue to check your answers. You could say that you can infer that there is more variability in the height of the boys because the range is larger and the interquartile range is larger than in the girls' data. You could also say that you infer that there is less variability in the height of the girls because the range is smaller and the interquartile range is smaller than in the boys' data. When you're making inferences, it's important that your inference includes at least two statements. At least one statement should be made about the measure of center, and you're probably going to be talking about the median. And you should have at least one statement about the measures of variability, such as the range and the interquartile range. Here are some sentence frames that you might find useful. You can print this page out, copy these down, or refer back to this part of the video at any point. Here's what you're going to do next. You're going to go back to the Google Doc that you opened. You're going to complete everything that's underneath the three red sections. So that includes the notes as you watch and participate in the examples and the try-its, the math excels that are listed, along with any IXLs that are required, and the check-in. You should use the support, enrichment, and additional practice sections as needed.